Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics, and today we will start with regression modeling, and in this unit we have 5 different lectures, and we start with simple regression modeling, the kind of requirements, the kind of need to solve the engineering problems, and some of the basic kind of checks we are supposed to do before we analyze any kind of engineering problems by using the regression modeling. So, first of all, what are the things we are supposed to learn in this particular unit? So, knowing the simple regression modeling, from a sample of data interpret the coefficients like slopes and the intercept. It is basically a structure of mathematical modeling, and the idea is just to connect the data and theory with this mathematical modeling, then it becomes a statistical modeling. And here the basic objective of this statistical modeling or econometric modeling is to derive the parameters value on the basis of the mathematical formulation of a model based on particular engineering theory. And second, knowing the importance of the residual in regression setup, that to connecting the game between dependent variable and independent variable. Then we like to know standard error of the estimate and how to interpret this particular item. Compute a coefficient of determinations, that is one of the basic or key indicator in the regression modeling to interpret or to analyze the engineering problem, and estimate the values of the dependent variable using the regression equation or regression modeling. Ultimately, the idea behind this particular modeling is to give comment about the dependent variable based on the information available on independent variable, and knowing the structure of multiple regression modeling, and then knowing the structure of multivariate regression modeling. Ultimately, if you go through various literature or the kind of cases and the application, so we have two things to highlight here: simple regression modeling, multiple regression modeling, then multivariate regression modeling, and finally statistical inference on parameters connecting to regression modeling in a bivariate setup, multiple setup and multivariate setup. So, that means technically, so regression modeling can be of three types, can be of three types, that is actually the kind of structure between dependent variable and independent variables. Let me highlight the basic structure. So, here first of all, what is regression analysis or regression modeling? It is basically a process of constructing a mathematical model or a function that can be used to predict or to determine one variable by another variable. So, it is basically a game between dependent variable and independent variables, and to predict dependent variable by the help of independent variables. So, so far as a classification is concerned, so regression modeling first of all can be divided into two parts: linear regression modeling and nonlinear regression modeling. And in this unit specifically we will highlight linear regression modeling, and after this particular unit we will touch upon the nonlinear regression modeling. In the linear regression modeling, so one of the basic assumption is the connection between dependent variable and independent variable in the form of linear setup, and in the case of nonlinear regression modeling, the connection or the establishment of dependent variable and independent variable in the form of nonlinear equation. But here in the case of linear regression modeling, so we have three different structure altogether. So, that means technically within the linear regression modeling we have three different setups, whatever we have discussed in the last slides. So, that is the simple regression modeling, that too simple linear regression modeling. Sometimes it is called as a bivariate econometric modeling, and then it is called as a multiple econometric modeling, and then multivariate econometric modeling. Okay. So, that means there are three different setups. The first setup is the bivariate structure, the second setup is the multiple structure, then the third setup is the multivariate structure. In the bivariate structure, the minimum requirement is the two variables, and that too one is classified as a dependent variable, another is classified as independent variable. In the case, for instance, it is in the bivariate setup. So, we can write simply like y equal to function of x, that is the only one variable, and in the case of multiple regression modeling. So, we have y equal to function of x1, x2 and so on, and in the case of multivariate regression modeling, this is multiple regression modeling and multivariate regression modeling. Here it is the game between y1, y2, y3, okay, as a function of x1, x2, x3 and so on. So, that means we have more number of dependent variables and more number of independent variables. In the case of multiple regression modeling, so we have one dependent with many independent variables, and in the case of bivariate econometric modeling or simple econometric modeling or simple regression modeling, we have one dependent variable and one independent variable. That is why we write y equal to f of x. So, it is one to one game, then one to many game, then many to many game. So, these are the basic classification of econometric modeling, that to engineering econometrics in a linear setup. So, in a linear setups we have three different engineering econometric structures. So, bivariate format, where we have one dependent variable with one independent variable, multiple format or multiple econometrics modeling. So, where we have one dependent with many independent variables, and then in the third setup we have many dependent variable with many independent variables. So, which particular technique we have to choose, that depends upon a particular engineering problem. So, looking into the particular engineering problems, we may use bivariate econometric modeling, or we may use multiple econometric modeling, or we may use multivariate regression modeling. It is the process of simple to complex. The bivariate econometric modeling or bivariate regression modeling, which otherwise called as simple regression modeling, is very simple and very easy to handle and very easy to interpret. Then the complexity will start when we are connecting many independent variable with dependent variable, and again the complexity will be more interesting and more significant when we have a setup where more dependent variable with more independent variables. And in the econometrics, engineering econometrics, we have a structure called as endogeneity issue, and in the kind of multivariate regression modeling, we will find such kind of endogeneity issue to address a particular engineering problem. So, where we will find bivariate kind of linkage or bidirectional kind of linkage. In fact, in the bivariate setup and typically simple regression modeling and then multiple regression modeling, the requirement is a univariate kind of linkage, and that is what is called as a unidirectional linkage, where once you fix the dependent variable and that particular variable cannot be further treated as a independent variable. But in the case of multivariate regression modeling, so this the particular dependent variables can be considered as a a predictant variables, and at the same times it can be having a role of predictor rules. So that's why it is more complex and more complicated. So in order to understand the particular setups, how to develop this model and how to connect to a particular engineering problem, and what kind of results you can obtain, and how to interpret these results for analyzing these engineering problems. So these are the things first first we like to know, and then we move with bivariate to simple to multiple, and then multiple to multivariate. That is the procedures we have to follow to do the kind of things as per the particular requirement. So basically we will be dealing with the simple regression modeling, multiple regression modeling, and multivariate regression modeling. In the simple regression modeling, it is a one-to-one game. Multiple regression modeling, it is a one-to-many game, and multivariate regression modeling, it is the game of many dependent variables to many independent variables. So this is the second level classification of regression modeling in the basket of engineering econometrics techniques. Then we will analyze, or we will connect with the different kind of engineering problems, and to see how these problems can be analyzed, and what kind of inference will obtain to comment the engineering problems, and so far as the solution is concerned, or the kind of future forecasting is concerned. So here there are two parts. Basically, so far as the objective of this particular technique is concerned. So one part is the estimation, that's the predictions, and the other part is the forecasting. So with the given setup, so we first try to find out the predicted line, and then we will do the forecasting for the future requirement. So it will give you some kind of future path on the basis of the estimated models or estimated regression line. So how is this particular steps, and what are the ways we can develop such kind of scenario. So let us see, or we will analyze as per the particular requirement. So in the meantime, so what I like to say that we can start with a simple regression modeling. So what I have already mentioned, it is the game between two variables. One is a dependent variable and one is independent variable. So that means usually the structure is like this. The structure is actually okay. So the structure is like this. So this is actually the particular structure here. So here actually the path diagrams will be like this. Y is a dependent variable, and then this is actually x is a independent variable. So the signal will be dependent variable, and this is the independent variable. Otherwise, if you don't write dependent variable identity or independent variable identity, the simple indication can work out. That's the kind of x to y. So that means in other way we can connect like this, x to y. So in functional forms we can write like this, y equal to f of x. So that means how x can influence the y. This is the basic understanding about the simple regression modeling, where y is declared as a dependent variable and x is declared as independent variables, and our job is to predict the y on the basis of x availability. That's what called as a predictor or explanatory variables in a particular engineering process. So likewise, so we have to actually move on to this particular technique and to analyze the requirement. And in the process of regression modeling, whether it is a bivariate structure or multiple structure or multivariate structure, we have some kind of basic requirements, or what is called as necessary requirement, and that too we must have before we enter to the game. And once you enter to the games, then we have also some of the basic requirements we are supposed to check and clear for for further advancements. So what we will do here, we like to know what are the minimum requirements before the game and what are the minimum requirements after the games. Then the process will be complete and as per the particular problems requirement. So first of all, the first hand requirement is at least 2 variables in the system, otherwise this technique cannot be applied. So at least 2 variables in the system. If that is the case, it is called as a simple one or bivariate one, and if it is more than 2 variables, then either it will be multiple one or multivariate one. So depending upon the theory and the kind of structures, so we can connect either with multiple regression modeling or multivariate regression modeling. Then the second one is the second requirement to start the process is the declaration of dependent variable and independent variable, because here the need is that in the case of simple and multiple, that is one basket, and multivariate is another basket. In the first basket, where we have a 2 different structure, the simple and multiple, but the requirement or the structure is the unidirectional, where every time independent variables will influence dependent variables, but dependent variables simultaneously will not influence the independent variable. But in the case of second basket, where we have a multivariate, so here all the variables may cause each other, and that is what is called as simultaneous equation modeling, or it is called as structural equation modeling, and that is how this process is very complex. And for that, the declaration of dependent variable and independent variables are must. If in a particular problem, if your declaration is one dependent variables with one independent variable, then you can use simple regression modeling. If your declaration is one dependent variable with multiple independent variables, then the requirement is multiple regression modeling. And if your theory will give you the indication about more dependent variables and more independent variables, then the requirement is the structural equation modeling or simultaneous equation modeling. In other words, called as a multivariate regression modeling. And the third requirement is you must have a theory. If not, then you must have logic to integrate dependent variable to independent variables. Without logical support or without theoretical support, we should not start with this kind of predictions or this kind of modeling. Otherwise, the particular process will be called as spurious regressions, or sometimes called as a nonsense regressions. So before you start establishing the relationship mathematically or functionally, so we must have a theory behind it. So that means if you say y and x, so there is a logical reasons how x can influence y or how y can influence x when in the case of multivariate structure. So as a result, you should be very clear, and means you must be very focused and then apply as per the particular requirement. For instance, we like to predict productivity of a particular industry, and that too with the help of infrastructural availability. So here the assumption is that more is the infrastructure, both in terms of quality and quantity, more is the kind of productivity of a particular industry. So that means technically infrastructure in terms of quantity and quality can have positive impact on productivity. So that is the basic theory, and yes, theoretically we convince that having more infrastructure or better infrastructure both in terms of quantity and quality, so the productivity of a particular industry will be up. And if the infrastructure availability both in terms of quantity and quality are lacking or at the low level, then the productivity of a particular industry will be low. and we have lots of literature, or we can have a lots of theoretical support to justify this particular fact. Since we have the understanding and we have the literature to say that infrastructure can be the a cause and the effect will be on productivity, so we can regress infrastructure with productivity of a industry. Then the issue will come whether the productivity will influence either means only through infrastructure or any other component. So then the complexity will start, and you have to find out the kind of you have, means it is a kind of search process to justify whether you will restrict your model to bivariate setup where you can integrate the productivity with infrastructure only, or we need to predict the productivity with respect to infrastructure and some of the other factors as per the particular production industry. And sometimes there is a possibility that the productivity of a industry also influence infrastructure. So then the complexity will be very high and it will be more interesting. In that case, we will move into the structural equation modeling or simultaneous equation modeling. But in the first instance, you start with the simple one by integrating independent variable to dependent variables, and that to the kind of requirement of or the ability of both theory and a logic. Sometimes inbuilt theory is there, you need to just verify the theory, and sometimes it is a exclusively new kind of thought, and for that you have to develop some kind of logic before you start doing the modeling, because modeling is a kind of mathematical process. So, but econometrics is not only mathematical process, it needs to justify the facts and figures. So, in addition to mathematical concept, we have to integrate with the statistical way of thinking, and then theoretical way of thinking. Then we can merge, and as a result we will have a engineering econometrics modes of thinking. So then in the next requirement is the declaration of sample size. So in this case there are two things: sample size with respect to variables, and then the kind of the type of on data. So maybe time series, cross sectional, pool or panel. So we have we must have a very clarity here on the basis of n and k. N is the sample size and k is the number of variable in the systems. Of course, in the bivariate setups or simple setup there are two variables, but in the case of multiple and multivariate setup you have a more number of variables. In that case k will be greater than to 1. So that means, so far as sample size is concerned, so we have a optimum balance or good balance between n and k. So the regression requirement is that n should be substantially greater than 2k. So that means the sample points will be substantially higher than 2 number of variables in a particular setup. For instance, if it is 2 variables, the sample size should be more than 30 or more than 50. But if k becomes 20, so your sample size should be actually 200 or 2000, like this. So it depends upon the kind of problem to problem, but every times the essential requirement is that n should be substantially greater than 2k. Even n cannot be equal to k. So you must be very careful. So the difference between n and k, that is the sample size and the number of variables, should be substantially very high and positive. So higher the difference, higher is the accuracy of the model and accuracy of the fit and accuracy of the regression modeling. Lower the difference, lower is the accuracy, and it will take you to the low fit, and the fit may not be statistically significant or not justified. So, that is why one way to justify your relationship or modeling is to have a more sample size, that too the big difference between n and k at a positive way. So, that means technically n should be substantially higher than 2k, and the difference between n and k, that is what is called as n minus k, is called as a degree of freedom. So, other way to represent the kind of scenario is higher the degree of freedom, higher is the model accuracy, lower the degree of freedom, lower the model accuracy. So, we have to bring high model accuracy by having more degree of freedom, and that too the difference should be substantially high between n and k. And so, that is one of the strong and basic requirement in any kind of regression modeling, whether it is a simple structure, multiple structure and multivariate structure. In fact, in the case of multivariate structure, k can be further divided into the kind of dependent variable and independent variables, while in the other case, in the simple and multiple, so every time the kind of dependent variable is 1, but in the case of multivariate, so the dependent variable and independent variables may be different. So, so we must be very careful how to fix the sample size and the kind of degree of freedom. And next requirement is the data visualization. So, that means means we start with the simple ones where we have two variables y and x, and the process of econometrics is that not to build the mathematical model, we have to transfer into statistical form of the models, and to validate this model, so we must have a data behind all these variables. So, so we start with the simple one, let us say y equal to function of x, that is it is a kind of functional form, but ultimately we start with a simple way of thought that since it is a linear regression modeling, we may start with let us say y equal to alpha plus beta x, but in reality when we have a problems, we may not know whether it will come to the linear modeling or it will come to the non-linear modeling. So, what is actually required or how to clarify the particular issue is you have to go for data visualization. So, data visualization will give you the clue that whether the particular functional relationship will be linear one or non-linear ones. If it is linear ones, then whether it will come in a downward shape or straight line shape or something like kind of 45-degree angles, whatever may be the way. So, it will give you some kind of a basic inference about the variables and the kind of functionality. Then of course, through regression modeling we can actually validate the particular thought or bring the strength to this particular thought. So, one of the basic requirement again in the process of regression modeling is the data visualization. So, having good visualization, in fact I have already mentioned in the second unit, data visualization is not a one step process. There are various ways you can visualize the data, a simple line gram to bar diagram, something like that, and like to know how is the particular structure, understanding the data, the structure of the data, the nature of the data, the sample size, the sampling structure, all these are basics for handling the particular issue, without which it is very difficult to address these things as per the particular requirement. So, data visualization is one of the strongest requirement for regression modeling, because it will take you to the path of either simple one or multiple one or multivariate one, and that too whether you are in the process of the linear modeling or in the process of nonlinear regression modeling. And the next requirement is reporting the descriptive statistic against each variable. So, without knowing the descriptive statistics, you are not sure whether the particular data corresponding to that particular variable is very consistent and very stable. Sometimes the data may have outliers problem. So outlier is a concept where most of means it is a data point which is exclusively or highly distanced from other data point. For instance, so in a kind of plotting, most of the data points are here in this particular boundary, but one data point will be here. So now if you are clubbing this all these data points in analysis, definitely the problem will be, or the kind of analysis will be biased, because it will give you lots of volatility or variation. So that means the dispersions of this particular data set will be very high. And if you remove these data points and just take this much of data point, then the variation will be low, and this will strengthen your modeling process. But the question is there are two things, to identify the outlier, and second thing, whether to remove the outlier, or whether you are supposed to do something to materialize the kind of a requirement. So it depends upon the data structure. If it is the case of cross sectional data, then it's very easy to drop that data point, and then you handle the problems with other data points. But in the case of time series data, you cannot just drop this data point, because it will bring you the inconsistency in the process of time series data. And in the same times, whether it is a cross sectional kind of setup or time series setup, if it is the presence of outlier, so one solution is to remove the outlier and handle the problem. That will give you some kind of unbiased results. Otherwise it will give you to some biased result. And in other instance, you can remove the outlier, and then you solve the problem, and there is a high chance the results will be completely unbiased, and provided there may not be any other obstacles, and these obstacles we will discuss in later stage. And in the third case, so there will be a issue of some kind of outlier, but with the manipulation of data or normalization of data, the degree of influence, that to the degree of influence of this particular outlier may be minimized. For instance, the first end data, and you can analyze, and then log transport data or fast difference transport data, if you will analyze, then you will find big difference. In the log transport data, the volatility will be very low, and in that case the impact of outlier will be minimized there. But in the case of original data, the impact of outlier will be very high, and in this case the particular model fit will not be very good, and it will not give you some kind of unbiased results. But in the context of normalized data, where the impact of outlier is minimized, so you may get some kind of perfect result, and that result may be completely unbiased. And that depends upon means how to understand, how to bring that particular setup. So the typical requirement is to check the descriptive statistics, and so the descriptive statistic, that to mean, median, mode, maximum, minimum, then the standard deviation, variance, skewness, all these things basic statistic you have to report. It will give you some kind of indication. Sometimes there is a high chance that in a particular variable all the data points are same. So in that context, so the standard deviation equal to 0, and if all the data points are same, whether it is with respect to dependent variable or independent variable, so you are not in a position to do the regression modeling, because it going against the system. So one of the requirement of regression modeling, that too with respect to data, there is a uniform data availability for both x and y, and within the x, so all the data points should be different. There should not be similarity if all the data are not different, they should not actually same. If all the data points are same, so that means this is going against the regression modeling. As a result, so we should not analyze, and if you analyze, the results will be completely indeterminate, and that too completely unbiased, completely biased. So it will go against the regression modeling setup. Of course, we have a concept called as there is a concept called as a Gauss Markov theorem, and popularly known as a blue theorem based linear unbiased estimator, and most of the regression modeling output will pass through this Gauss Markov theorem. That is how the validity check of the particular econometric modeling, and where the particular model will be declared as a best if it is in the context of linear modeling. So, linear, unbiased, and must have a minimum variance. So, the presence of outlier again, and without checking the descriptive statistics, so the particular regression output may go against the blue theorem. If the particular output is going against the blue theorem, then the particular output cannot be used for analyzing any engineering problems or the kind of any kind of prediction. So, to normalize all these issues, or bring the efficiency of this particular econometric modeling, and that to the solution to the engineering problem. So, you are supposed to check the descriptive statistic against each variables, and then then you like to manipulate or normalize as per the particular requirement. So, regression modeling will not have any kind of issue whether you are using the actual data or you are using the normalized data or manipulated data. So, ultimately we need to develop a model which can help some kind of solution to a particular engineering problem. If that model is actually the model must be very perfect. If the model is not perfect, then then we should not think about the perfect solution. So, the requirement of the perfect fit model depend upon the basic requirements of the basic checks. So, this will give you some kind of boost to the process of efficient model. And then we like to report the correlation statistics, because regression is a kind of modeling where we have a causality issue, but the process of causality we can start when there is a kind of relationship. That is how we connect with the theory and the kind of logic. So, the reason behind establishing a logic and connecting to the theory is that we like to justify that there is a kind of relationship, and that relationship technically can be quantified before you go to the regression modeling with the help of covariance and correlation. So, that is why before you start processing of regression modeling, you are supposed to report the correlation statistics or covariance statistic. It will give you some kind of confidence that yes, there is a relationship, and that too with the help of theory and logic, and that too with some kind of quantifications through covariance statistic and correlation statistics. And this is again one of the basic requirements of any kind of regression modeling, that too whether it is a simple one, multiple one, or multivariate one. And the last but not the least final check is the multicollinearity issue. This is actually typically econometrics terms or statistical terms. We have a separate lecture for that, but in the meantime I let you know that multicollinearity is a problem where there is a existence of linear relationship among the independent variables, and that too this particular component is always there, or there is a chance of issue in the context of multiple and multivariate, but it is not the issue in the case of simple regression modeling or bivariate regression modeling. So, So the literary meaning of multicollinearity is the existence of linear relationship among the regressors, that is the independent variable. Since we are declaring that x are independent variable against the dependent variable y. So, if it is a single x, then there is no chance. If there are multiple x, that is the independent variable, say x1, x2, x3, then if they are independent, then the relationship between x1, x2, x1, x3 or x2, x3 should not be there. So, that means technically having correlation matrix that we have mentioned in the last step. So, it will give you the clear cut idea that whether there is a kind of relationship among the regressors, and in reality it is very very rare chance that you will find a situation where all the independent variables are completely independent. But with the help of correlation matrix you can actually you can mark and you can justify, and what is needed for this particular requirement for the regression modeling. You like to check that whether there is a correlation among the regressors. If not, then this is very perfect and that is the best, and if it is, then you are supposed to check whether they are statistically significant or not. If they are not statistically significant, then you can go ahead with the particular regression process. If they are statistically significant, then you have to work out differently, and the first step of the process is how to minimize this particular relationship or a degree of association. And so there are many solution tricks how to reduce this particular relationship, means the quantification of this relationship, and before you start the regression modeling. Until unless you minimize this particular relationship, that means statistically significant to statistically not significant, then you can go for regression modeling. If not, then it is a big issue before you process the data and to analyze the problems as per the particular engineering requirement. So, you must be very careful how you have to deal the situation. And then finally, regression modeling means what is the after process. In the process of modeling, the idea is to develop mathematical model, then statistical models, and when we connect with the data, so the modeling process will give you the parameters value, and after getting the parameters value, and that is how the regression modeling is all about. For instance, in the middle stage we have a regression output, and before processing this output we have some requirement which we have already discussed, and then in the process of regression modeling you will come with some kind of an output that is called as a regression output or econometric output, and then what kind of things you have to that means what kind of basic checks we are supposed to do before you start processing the output for solving the engineering problems. So, first of all you have to report the estimated parameters with the help of some kind of formulation or calculation. Then report the error terms, which is the difference between the dependent variable actual and the dependent variable predicted. And third check is the requirement of sum of the error term. If the model or the functional goodness of fit or functionality of this particular process is accurate, then the error term, sum of the error term should be equal to 0. So, the issue is here the error term is the difference between actual and predicted. So, there is a high chance that sometimes the difference will be positive and there is the difference will be negative, and since the actual plotting will be, for instance, it will be like this. The actual plot the actual plotting will be like this, and the predicted line will be like this. So, as a result we have some positive difference and we have some negative difference. Now, the basic requirement of the regression modeling. Before we start the estimation, we will be in the best if the line in the straight line or predicted line should be in between middle of these points. If that is the case, then you will find 50% of the error terms are at the positive sides and 50% of the error terms are in the negative sides. As a result, if you sum up, then the sum will be equal to 0. If that is the case, then your model will be considered as the perfect fit in the first instance. If not, then you can actually rectify and try to restructure again, so that this particular structure can happen, and then check the variance of the error terms. So, the variance of the error terms should not be equal to 0. If that is the case, then it is very difficult to again analyze the problem. So, there should be some kind of error variance, but that error variance should be at the minimum level, and our aim is to how to minimize this error variance or minimize the error terms. Then report the standard error of the estimates, which is one of the basic requirements for inferential parts of the regression modeling, because the first part of regression modeling is to have estimated output, that is the process called as a first hand output. Then before you use this output for solving the or analyzing the engineering problem, you need to test it, that means technically we like to check the reliability part of the estimated model, and for that standard errors will help you lot to validate the outcomes as per the particular requirement. And then we finally test the entire model, the estimated models, because the estimated models will give you lots of outputs that includes the parameters value, then the kind of goodness of fit that is declared in the form of coefficient of determinations, and some of the other statistic which we call as ANOVA, analysis of variance, error sum square totals. These are the items called as regression output, which we will discuss in details in the next lecture. But ultimately, after having all these outcomes, it is your duty to test and check whether it is on the line as per the requirement of regression modeling, and then finally you will go for checking the diagnostics of the models, where we have multiple things we have to check and bring into the kind of consistency level before you before you analyze the problem and comment about the process, and to go for the kind of prediction and forecasting. And with this we will stop here, and we will discuss in details about this particular processing in the next class. Thank you very much. Have a nice day.